About software architecture, we have seen that software architecture is nothing but deciding or planning what we are going to build even before we start building the system, right? Then we gone through the characteristics of a software system, what the software system should be capable of. In this session, we will see how the software components are organized. Basically, the software architectural patterns, right? All the systems are not organized in the same way. Different systems are structured differently depending on the business goals, scalability requirements, deployment models, right? Some systems are built as one single application. Some are built into independent services. Some communicate through events, right? Some are designed specifically for cloud native environments. In this session, let us understand the major ways modern software systems are organized. Monolithic architecture. Okay. So, what is monolithic architecture? It is a single deployable unit, everything combined in one module. Okay. All the submodules stay together. All the components are deployed as one model. This is a this provides a simple initiative, but when you try to scale it, it becomes difficult. As the system grows, it difficult to adjust all the submodels and components into one single large model, right? And it also affects the maintainability, and it becomes more and more complex as it grows. Okay. Example of monolithic architecture, we can say a small HR management system, right? So when we know that this is not going to scale, or we need a simple start and we don't have any complex enterprise logic, in that case, we can go for monolithic architecture. So this is here we are going to cover all of this at high level. In the upcoming videos, we'll take each architecture pattern and um, go in depth with real um, system example. Okay. Okay. The next one is layered architecture, okay. What is layer architecture? Here, the components and the units are arranged in such a way that they are in layers. Okay. Um, Example, so when there is a system, it has a presentation layer which deals with the UI, user interface, how user sees the system, what all options we are providing to that presentation layer. There is a business layer where the business core logic resides, and there is a data layer, right, where we store the data. So here we have separated the concerns into layers. Okay, this is layer architecture. Okay, benefits. What are the benefits of this layered architecture? Okay, it is maintainable. See, when we have separated the components, it is easy to maintain them. When I have something to change in the business logic, I don't have to touch other two components. I only work on business layer, and I'm very much sure that other two models are integrated and kept unchanged. Right? This is the advantage that layered architecture provides. Example, all the traditional enterprise applications follow the layered architecture. In fact, you have seen the um, MVC, right? Model view controller. That is also one of the layer architecture pattern. Okay. The next one is microservices. Microservice architecture. Okay. Um, this is the most trending and recently being used architectural pattern. Okay, here each um, service is independent. Okay, for example, take a banking application example. Here, the user component or a service is independent on the accounts service, right? They are independently deployable. When I um, change anything on the user side, or say update, you want to use update the user fields, you only update the user service and deploy only that. Your other components, accounts or a summary, all other two components are independent of that. How do they communicate? They communicate through API. The user service exposes API. The other service, account service, if it wants to use the user service, it makes the API call, get API call, give me this user detail or add this user detail, post user call, right? So this is how they all communicate. All are um, organized in a small modular group, right? This is one group, this is second group, this is third group. Okay, this is a microservices architecture. What is the benefit of microservice architecture? It is scalable, highly scalable, right? When you have a new requirement, right? You want to add category-wise spending. You just create another model. Now you are not touching any other existing models here, right? You just have another module as a service, then start using it. You expose API through this category spending service, and if the account and user some models you want to use that, they can consume it using the APIs, right? This is highly scalable and deployability, right? This is highly like you're not even touching or bothered about other existing systems. You build this, you design this, build this, and deploy this. This is completely independent of other. Okay, so what are the challenges of this microservice architecture, right? This is a distributed complexity, right? When you keep on adding in the real enterprise system models, it becomes hard to maintain the distribution, right? If there is one common feature that you want to add to all the models, then you have to go to each module and change that. In opposed to monolithic, if there is a change, that change will take place in all the components belonging to that, right? It is just changing in one place, right? Yeah. And network communication. The major one of the bottleneck here is the network communication. We just explained this, right? User and accounts communicate through API. So that is, if the API is not available, or if the service is not available, then the operation is entirely affected and it adds latency. The service has to travel from accounts to user. That is the latency in getting the user information, right? So these are all the some challenges of microservices architecture. Example, Netflix, Amazon, these enterprise systems are built on a microservices architecture. The next one is event-driven architecture. Okay, so what happens here? The systems or components communicate based on demand, right? So if there is a event, then respond to that. Or if we want to, one module wants to communicate something to other module, it sends a message. Okay, here the um, events is a trigger and messages is the trigger. They communicate through events and messages. Okay. Event-driven, what example we can take is, okay, we can use this in deployment, simple example. So, you schedule a deployment at this time. Okay. There is an event triggered at this particular time. Okay. This is the event-driven. At this point, this happens. Okay. So if something changes in this system or a component, then it takes some actions so that it affects the other system. This is event driven. Okay. Example, you place the order, okay, you make the payment and you get the notification. So now placing order, okay, will trigger the payment, that will trigger the notification. Okay, this is event driven. Next one is serverless architecture. Okay, this is mainly this is used in a cloud managed infrastructure. Okay, there is no single server which is serving all this. These are all like distributed environment. There are multiple millions of servers and virtual machines operating. Right? You example is GCP, Google Cloud Platform. There are multiple regions, zones, and that's entire GCP infrastructure is serverless architecture. Okay, what is the benefit of this is elasticity. You can change or modify or adjust the number of servers that are up and down. That provides elasticity. Sorry. Okay, and it reduces the infrastructure management. Since all these components are running independently, it reduces infrastructure management. Okay, that is the serverless architecture. Okay, so when it comes to enterprise applications, right, there is no universally best architecture pattern. Architecture is always about trade-offs. A pattern that improves scalability may increase operational complexity, right? We have to choose what is more critical and important to us. A pattern that simplifies development may reduce deployment flexibility, right? So, at any given point of time, what are my requirements? If security is my high requirement, or I'm more concerned about scalable, I'm okay to have lesser security compliances, but my systems should be scalable. Okay, so architect selects patterns based on the um, systems require characteristics and business constraints, right? Yeah. So in upcoming videos, we will see more about each one of these explained in detail with real enterprise applications. Okay. Thank you for your valuable time.